All right, we are working on lesson 2.5. Do the warm-ups. I will give you a few minutes, and I will help those of you who need that. Okay, so look at the warm-up for lesson 2.5. Okay, what are we doing here, guys?
I'm confused.
What is the...
We are finding the solution for x.
We're solving for x. So the first thing you need to do is what?
Combine like terms.
Combine like terms. So do these have the same denominator?
Yes.
Yes. Okay, hold on. Let me get my little whiteboard. All right, will you read it to me?
Solve 1 over 7x plus 2 over 7x plus 20 equals negative 25.
That x was huge. Plus 20?
Yep. Plus
My hand slipped. I'm sorry.
equals negative 25.
Okay, why are we giggling over there? I'm not going to help you if you're not going to pay attention. All right, so combine like terms. So the like terms here are the stuff with the x. Where's my marker? My marker's not working. Oh, that one is. All right, so if I have 1x, 1/7 x plus 2/7, the denominators are the same, right? So I just have 2 plus 1, which is?
3.
So 3/7 x plus 20 equals 23. Sorry, negative 25. Should have been a holiday. All right, so now I need to move what? The 20. So since it's addition, I'm doing?
Subtraction.
So minus 20.
And so it's negative 45.
So I'm left with, why is spam calling me? 3/7 x. It says spam risk. Oh, man.
Same.
3/7 x. What is negative 25 minus 20?
Negative 45.
Yes, because it goes further negative. Negative 45. Man, I need to find a stylus. This is not working. So I have 3/7 times x. How do I get the x by itself? Divide the fraction. When you divide the fraction, you're technically what? Flipping and multiplying. Okay, so then that's gone. I'm left with x equals, what's negative 45 times 7/3? Negative 105?
That's what I got.
7 times 45 divided by 3?
Negative 315 over 3, which would be...
Plug it in. Any questions on how we did that?
No.
Okay, can you do the next one?
Yes.
Do it. Okay, so the meaning of the word dilate. When you have your eyes checked, the optometrist will sometimes dilate one or both pupils of your eyes. Dilate means to expand. Okay? So you see the picture of the eyes, the pupil in the center has grown larger. Okay, what does dilating do in your eyes specifically? Yes? Okay, there's a specific reason your eyes actually dilate. Yes, Cindy?
Well, usually it's when your eyes are trying to take in more light.
That's exactly it. It's trying to take in more light. So the darker it is, the bigger your pupils are, because it's trying to allow as much light as possible. When you go outside in the super bright sunshine, they constrict, so that way it doesn't handle all that bright light.
That's why in the morning your mother's wants to up and
We're all...
opens the window.
Exactly. Okay, make sure you go to the next screen and write in the vocabulary you see here. I'm going to go over it while you are writing. 7th grade, I need you to whisper, or you can't work together. So a dilation is a transformation in which a figure is made larger with respect to a point called the center of dilation. In a dilation, the angles of the image and the original figure are congruent. So if you see this picture, I would sketch this in your journals. So you have your center of dilation is this point on the corner. And here is your shape, and it has been enlarged or dilated, as you can see in the blue image. Okay? Scale factor is how you are going to determine how much something dilated. Okay? You need another moment to write this?
No.
There's a few that do. I'm going to give you just a moment. Example 1, in your journals. Tell whether the blue figure is a dilation of the red figure. Just sketch this super quick, guys. Okay? Is the blue figure a dilation of the red figure?
Yes.
Yes. Because the red is being dilated to being blue.
It's bigger.
So the lines are correspondent to a center of dilation.
Yeah.
And you can see that you have corresponding vertices.
Yeah.
So you're going to take a straight edge and see if you can't find your center of dilation. So yes, the blue figure is a dilation of the red figure. Is it larger or smaller?
Larger.
The blue figure is larger than the red figure?
Oh, it's small.
Yes, it is smaller, so it actually constricted, but
Okay.
semantics. Okay, what about for B? Elena?
It's a translation.
It is a translation. It just moved places. It did not dilate. So the blue figure is not a dilation of the red figure. Okay, make sure you have that in your journals, and then go do try it's 1 and 2. Does anybody need me to leave this up for a moment?
Oh, real quick.
Yep, no problem.
Wait, do we write the? Do we also do the one with the line? No.
So when you're dealing with dilations, specifically in a coordinate plane, this is how you're going to be able to measure things. So there's 2 different types of dilation. We've seen them. We've talked about a reduction, which is what we had in our example 1, where it reduced. And then the other one is an enlargement, like your pupils dilating an enlargement. Okay? This is the formula, for lack of a better word. Shh. Okay, good. Formula. Always my lovely children. This is the formula, for lack of a better word, that you need when dealing with dilations. Okay? When your number, represented by K here, is greater than 1, the dilation is going to be an enlargement. So think of this as multiplication. I'm dilating the x by 2. So if it says 2x, I'm enlarging it by 2. Okay? If it's between 0 and 1, it's a reduction. So if it's a fraction or a decimal. Are you guys hearing me? Because I'm going to have to help you if you're not listening. So if this K was like 1/2, that's a reduction. It's like taking a whole number and dividing it by 2. I'm reducing the size. So if we look at this, comparing the red to blue, it's what kind of dilation? Go ahead.
A reduction.
No, red to blue.
Oh, it's not.
It's an enlargement. If I go from blue to red, it's a reduction. Okay? All right, so let's do example 2. Put this in your journals. So you're going to use scale factor. The scale factor is that numbers that will tell you whether you're reducing or enlarging. So it'll either be a whole number greater than 1, which means it's an enlargement, or less than 1, which means it's a reduction. So here are the vertices to a triangle. So you're going to sketch this. You're going to sketch these and draw the image after a dilation with a scale factor of 3. 3, is that greater than 1 or between 1 and 0? Greater. So is this going to be an enlargement, Samuel, or a reduction?
It would be.
If it's an enlargement because it's greater than 1. So already we know the type of dilation is an enlargement. If you would like graph paper, there is graph paper over there you can cut out. So the first thing we're going to do is do the algebra of it and multiply 3 times each of our coordinates. So we're going to say 3 times x, 3 times y for every single one of these points. So you don't have to draw both shapes here. We only have to draw the actual new shape. So let's do the math. We have a, which is 1, 3. We're going to multiply both of these by 3. What is 1 times 3? 3. What is 3 times 3?
9.
9. So our new point would be 3, 9. And this is an enlargement. Does it make sense so far?
Yes.
Okay, let's look at B. We have 2, 3. We're going to multiply both by 3. What's 3 times 2?
6.
And 3 times 3?
9.
So B is now at 6, 9. I know I can't talk sometimes. All right, and C, 2, 1. Again, enlarging both by 3. Our new point would be 3 times 2.
6.
And 3 times 1?
3.
So 6, 3. So these are the vertices we're going to sketch in our new coordinate plane. Here's our coordinate plane. So 3, 9, 6, 9, and 6, 3. Connect the dots. You now have an enlargement. It's a pretty small triangle, so it was already really small.
Yeah.
If this is an enlargement. So the last statement it asks you is identify the type of dilation. Oh, the red is the beginning one. I was like, that makes no sense. So they drew the beginning one, but that's fine. You don't have to. The blue one is the new sketch. So yours in your journal should be the blue one. And yes, it was an enlargement. Excellent. I'll give you a moment to finish that. Oh, look, they also drew your... what is this called? The lines that show your center of dilation. Couldn't think. So what's our center of dilation here? Where on this graph is the center of dilation? On the origin. Very good. 0, 0.
Oh.
Oh. All right, I'll give you a few minutes to finish sketching that and then go. Example 3. The vertices of a rectangle, so we have 4 points this time. We're going to draw the image after a dilation with a scale factor of 0.5. What kind of dilation is this going to be?
It's called
Reduction.
There you go.
Yeah,
Reduction.
It's a reduction because it's less than a 1. It's less than a whole number. So let's do the math first. So we're going to be multiplying the x and y values by what?
Half.
1/2.
1/2 or 0.5? All right, so our first point is W. You're writing this in your journals, example 3. We're multiplying 0.5 times -4 and 0.5 times -6. What is our new x value? What is -4? What's half of -4? -2 and half of 6? -3. So our new W is -2, -3. Very good. X, we have -4 and 8. Multiply those times half.
-2 and +4.
Very good. -2 and +4. Excellent. Y value, 4 and 8 times a half. 2 and 8. 2 and 4. There you go. 2 and 4, both positive. I'm so glad Max is participating.
Wow. Good job, Max.
They don't join in. They just tell you good job.
2 and 3. 2 and -3.
2 and -3. Very good. So terrible. All right, so they draw the original rectangle. You can see it drawn here in red. I do not require that in your journals. You just need to draw the new one. However, the new one is what kind of dilation?
Reduction.
So it's going to be smaller than this red rectangle, so it's probably going to be on the inside of this rectangle. So our first point is at -2, -3.
Yes.
Next point is at -2, 4. Next point's at 2, 4. And our last point's at 2, -3. Connect the dots. And you see a wonderful reduction.
I'm trying to write all of this down on this thing.
It's because you keep talking. Stop talking and magically your pen writes faster.
Don't cry, Eric. Don't cry.
All right. Shh. Any questions on how to sketch this? Any questions on how you found the new points? Any questions on what type of what type of dilation this is? What's the scale factor? 0.5. The scale factor is what you're multiplying to make the reduction. Very good. Okay, once you've written this in your journals, go do your next set. Dilate the trapezoid using a scale factor of 2. What kind of dilation is this trapezoid going to be? Enlargement. Very good. Enlargement. Okay. And then we'll translate it 6 to the right and 2 up. So let's do the math part. They're sketching it. I don't want to sketch it. I want to do the math. Okay, here we go. So dilation, we're multiplying every point by 2, right?
Yes.
So A, oh, they're sketching it. Yes, -4, -2. B would be
-2, 2.
-2, 2. C would be
0, 2.
0, 2. And D would be
0, -2.
0, -2. You can see that they've sketched it. I would just do the math over here because we're going to translate it now. Okay, so we're going to translate it which way?
6 units right and 2.
6 to the right and 2 up. So my X value is getting a +6. My Y value is getting a +2. 6 to the right, 2 up. Both positive. Comprende?
Yes.
Yes.
All right, so now we take our new point over here. This A. This is why I would have done it all mathematically first. And we're going to say +6 and +2. So this is where it ends up. From the A, we go over 6 and up 2. Okay, from the D, we're going to go over 6 up 2. Well, they probably went B next. B, over 6 up 2. C, over 6 up 2. And D, over 6 up 2. Okay, on your example in your journals, don't sketch all of this, just sketch the final one. I would much prefer to see the math over here. See what you've done there. Does that make sense?
Yes, ma'am.
Okay. So we dilated it by 2. The scale factor was 2. And then we translated it to the right 6 and up 2. Any questions? Not terrible, right? They're like, Okay, I'll give you a moment to finish that and then go to do the next try it. We're probably on self-assessments here in a second. All right, so this is try it number 5. Can somebody read the vertices off to me? Just read them.
Negative. Okay, so A is -2, -1.
-2, -1.
All right. B is -1, 1.
Ah. Go ahead.
And C 0, 1. And D is 0,
0, -1?
Yes.
Okay, so we're doing a dilation first, right?
Yes, ma'am.
Dilation of
3.
3. So we're multiplying everything in here times 3.
Yes.
So my new A would be -2 times 3, which is
-6,
-6. And then 3 times -1 would be -.
3.
Good. So my new B, -1 times 3.
-3.
And then 1 times 3. I'm going to put scale factor over here. Scale factor is 3. All right, C, a little rough. 0 times 3 is? 1 times 3 is? Good. And my last point is 0 times 3, -1 times 3. Okay, so you've done the dilation math. So now we need to do the rotation about 180 degrees. What is the rule for the rotation? Go ahead.
Opposite of already what it is.
So whatever X and Y is,
It's both negative.
Opposite.
they turn into whatever the opposite sign is. It's like multiplying times a -1, essentially. So A, negative times a negative makes that a +6 and a +3. I know writing with my mouse takes me forever. I'm sorry.
It's better than 1 is the added.
B. Okay, the next one is a negative times a negative makes this a. So +3, but the other one is now a -3. Okay, and then C.
0, negative.
Yeah, because 0 can't have a negative, and then -3. And then the last one, D. Again, 0 stays the same, and what's my Y value? +3. So this is the last coordinates you're going to graph. Oh, do you have to graph it? I don't think you have to graph it. So then that's just your answers, A, B, C, D. Any questions on this? This is number 5 in your try-its.
Yes.
I'll leave it up for just a second. Example 5. Put this in your journals. A wildlife refuge is mapped on a coordinate plane where each grid line represents 1 mile. The refuge has vertices listed here. An expression of the refuge can be represented by a dilation with a scale factor of 1.5. How much does the area of the wildlife refuge increase? All right, using the scale factor, is this an enlargement or a reduction? Enlargement. It's greater than 1. It's 1.5, right? So, let's use our formula. We're going to multiply both our x and y values by 1.5 to get our new coordinates. So for j,
0.
we multiply 1.5. We still get 0, 0. Didn't change at all. K, multiply both by 1.5, and you get
1.5, 4.5.
1.5 and 4.5. Are you writing this in your journal? At least you're listening. And L, multiply both times 1.5, and you get
6 and 0.
6 and 0. Very good. So it's asking, how much does the area of the wildlife refuge increase? So everybody got this? Because it's probably going to make me go to another screen. So when you graph this, there's the original, and you graph the new points, you can see the difference. Your friend is talking. So you see between the red triangle and the blue triangle, you can see we have extra space right here. It wants to know how much this increased. So we're going to, the original is how far across. Each one of these squares is a mile. So 1, 2, 3, 4. And how high? 3. So how do you find the area of a triangle? 1/2 base times height. Multiply. So you're going to do 1/2 of 4 times 3 to find the red triangle area. 1/2 of 4 times 3. Let me move my face. Okay, this base is 4, the height is 3, so 1/2 of 4 times 3 is what? Is 6. So the area of the red triangle is 6. The blue triangle, we're doing 1/2 of how wide is the mileage on this one? 6. And how tall is it? 4.5. So you're going to do 6 times 4.5 times 1/2. Okay, let's do it now. Let's see here. So there's your formula. Write this in your journals. That's how you find the area of a triangle. You need to memorize that, guys. You will see this again and again and again. Okay, so let's plug in our smaller triangle was 4 by 3, right? And so you do 1/2 of 4 times 3, which gave you 6. So the area of the red triangle, the original size of the refuge, was 6 miles squared. Okay, the second one was 6 by 4.5, right? Say yes.
Yes.
Thank you. So 1/2 of 6 times 4.5 gives you 13.5. So this is the size of the new refuge. The question is asking how much more space did the animals get? So what's our last step to find out how much more? Correct. We're going to subtract 13.5 minus 6 to get 7.5. So we increased the size of the refuge by 7.5 square miles. Okay, you need to have this written in your journals. Okay, you don't have to sketch it if you don't want to, as long as you have the math showing the dilation and then the area of the triangles. Okay? All right, is that all we have? Okay, so you need to finish through number 11 as homework. And that's it for today.